Hi, happy Sunday. Welcome to another episode of Secrets of a Maths Tutor. My name is Sarahlynn, the founder and head tutor of Bettering Youth, an academic tutoring company that blends in well-being coaching. And today we are diving deep into the wonderful language of fractions, decimals, and percentages. Now, like always, our Secrets of a Maths Tutor program is here to help your child, whether they are in year 4, year 5, so at the beginning of Key Stage 2, right through to GCSE level. Fractions, decimals, and percentages are absolutely everywhere. And how we figure out how to work with them really starts with a strong understanding of the basics. So that's what we're going to do today. We're going to make sure that we understand how we can convert between fractions, decimals, and percentages. When you're ready, grab your pencil and your paper and let's dive in. The first thing that we need to ensure our students understand is the presence of fractions, decimals, and percentages. Every single day, they are seeing these forms of a representation every single day, whether they are shopping, they're looking at sports, they're reading the news, they're cooking, or they're just in the playground sharing with their friends. They are encountering fractions, decimals, and percentages. That's why it's such an important skill and one that we're going to ensure they feel much more confident in by the end of this lesson. So how do we convert between all of them? One of my favorite ways to ensure maximum understanding is to show it visually. Now, in front of us, we have a triangle. At the top, it has fractions. To the left, we've got decimals, and to the right, percent. Now, as you can see, as we follow each of the arrows, there is a subject or a process that needs to be followed. So going from fractions to decimals, the process is to divide the numerator by the denominator. We will go through every single key word in this process in the following slides. So if you have a pencil and paper with you at the moment, try and take some time to write this process down because it is the core piece of information that we're going to unpick throughout the rest of our time together. So moving from fractions to decimals, we said that we're going to divide the numerator by the denominator. Then, if we wanted to move from decimals to percentages, we're going to multiply the decimal by 100. If I wanted to go backwards, I wanted to go from a percentage to a decimal, I would do the inverse, so the opposite, divide by 100. And finally, if I'm going from percentages to fractions, I put the percent over 100 and simplify. Now, like I said, I appreciate that there are a couple of words here that we may not feel comfortable with, so let's dig into a couple of them. The first thing that we want to ensure is an understanding of what each part of our fraction is called. Now, I've already mentioned it, but as a reminder, let's see if you can remember. What is the top digit of our fraction called? If you said numerator, you are right on the money, a numerator. So like I said, if you have your pencil and your paper with you, make sure that you're writing out these sections too, so that way there, if you forget when we're no longer in lesson together, you have it in your notebook. Now we've got the number at the top known as the numerator. Now the one at the bottom is down under, so that one is the denominator. Now this should feel familiar. Your child and yourself may find that these words are quite familiar because we've looked at them probably since year 2, year 3. So these are just vocabulary words that are rattling around in that brain of theirs, and we might need to pull them to the front. So our fraction has a numerator at the top and a denominator down below. Knowing that is going to help us when we use those words when I say how you're going to move from a fraction to a decimal. So, looking again, we have numerator being divided by the denominator. Now, in a couple of episodes previous, we went through what it means divide by. Now, what you'll see is that it looks uncomfortable. I've already kind of set up our division here, but it looks uncomfortable because normally we would have the bottom number inside the bus stop. However, if I did that, if I put my 10 inside the bus stop, what do we notice? Well, 7 doesn't go into 1, but when I put them together, 7 goes into 10, it goes in there once, which means that I actually have a whole number. Now, going from a fraction, which is less than a whole, right? 7 out of 10, if I have a pizza with 10 pieces and I've eaten 7 of them, that's not a whole pizza that I've eaten. So it should never have a whole number when we're converting from a fraction to a decimal. That's one way that you can ensure that you didn't do it the wrong way around. So we are putting our denominator on the outside. So grab your denominator from your fraction, pop it on the outside. That will ensure that you have a 0 at the front. And it shows like this. 10 cannot go into 7. So we put our 0. We place our decimal behind the 7. 10 doesn't go into 7, so we put a trailing 0, making that 70. How many times does 10 go into 70? 7 times. So going from a fraction to a decimal means that we put the denominator on the outside of our bus stop and just dividing. When we're looking at decimals, there's a couple of key words that we're going to need to ensure we have full confidence with. Now, this should look familiar to you and your family. It is a place value chart. Now, I've gone from thousands, hundreds, tens, and units on the left side of my decimal. And on the inside, I've got my tenths, hundredths, thousandths. Now, you'll know that when we put this line down the middle and our decimal, it's almost as if this unit is a 1 and the decimal is like a hypothetical one because it's also a circle. So it's like a mirror line is being presented here. And now we know that we don't have any once. That doesn't really sound good either, but we move straight to tenths. And tenths with a THS means it's less than 1 whole, which is why it's on the right side of our decimal. So if we were working, let's say, with the decimal of 23, or the whole number of 23, I would be multiplying it by 10, 100, or 1,000. So to multiply by 10, all I'm going to do is grab my number, and you can start with either number that you prefer, but I like to start with the largest number because it helps get it out of the way quicker. So I'm going to grab my number that's in the tens column, and I'm going to move it over 1 block, or 1 space in the place value chart. Now, the reason why I get to move 1 space is because I was multiplying by 10. And just like 10 has 1 0, our numbers will move 1 space. So I've moved from my tens to my hundreds column with the 2. Now I need to do the same thing with my units. My 3 moves from my unit 3, and it's moving to my tens column. Do you notice how I'm putting my numbers underneath them? I'm not beside, they're not way below, they're kind of sticking underneath my arrows, and I'm trying to stay as neat as possible. Now we'll see that I've got a 2 in the hundreds column, a 3 in the tens column, and I've got nothing to put in my units column. So we're just going to put a placeholder 0 or a trailing 0. Now, I can see that when I multiplied by 23, I now have 230. This same format will work if I use decimals. So if I started, let's say, with 3.72, and I wanted to multiply it by 100, how many spaces do you reckon I'm going to have to move? Do you know why you have to move 2 spaces? Because we're moving not just 10 times bigger, but 10 times 10, which is 100 times bigger. So what I'm going to do is grab my largest number, which is the 3 in the units, and I'm going to move it 2 boxes to the left so it gets larger. That 3 now sits in the hundreds column. Moving over to my 7 in the tenths column, it skips over the decimal because that's not actually a space, and it goes into the tens column. So that 7 now lives in the tens column. That 2 moves from the hundredths to the tenths and lands in my units section. So now I can see that 3.72 multiplied by 100 results in 372. Now you may be wondering, why do we need to know this skill? This is multiplying and working with decimals. Why do we need it for fractions, decimals, and percents? Well, the main reason is because when we are going from a decimal to a percent and a percent to a decimal, this is the skill that we're going to need to feel confident with. Let's look at the division side. If we are moving larger towards the left when we multiply, what direction do we go if we divide? To the right, exactly that. Let's look at how it works when we move from decimals to percentages. Now, because I would like to go to a percent, how many am I multiplying by? Am I multiplying by 10, 100, 1,000? Does it matter? It absolutely matters. Now, the way that we know how many we need to multiply by is looking at the word percent. Now, the word percent actually has 2 smaller words in it. Per means we're multiplying, and cent is the Francais version of the word hundred. That might sound familiar for some of our students who have practiced French in the past. So percent is per 100. So that means that we are moving our decimal by 100. If I had 0.84, I would be multiplying everything by 100. Let's see if I can grab a different color and show the jumps. Now, I don't have to worry about the 0 moving. I can go through the process, but it's just going to disappear. I will, though, grab my 8. So my 8 is in my tenths column, and I need to move it 2 spaces. So it jumps over the decimal into the units and lands in my tens column. I'll go over to my hundredths column where the 4 is. I grab that 4, moves past the tenths column, past the decimal, and into the units, landing in the unit or the ones column. So 0.84 times 100 is 84. This shows us that 0.84 converted to a percent is 84%. Now this all makes sense because hundredths is actually a number out of 100. And 84 ends in that hundredths column. So this 84 is actually the number that sits on top of this fraction. And we know that any fraction over 100 makes it into the percentage. There we are. Let's look at another example. Make sure you have that written down. Pause the video if you need to. I'm going to rub it out in a second and we'll look at another example. So that was quite positive for our Key Stage 2 students, so our Year 5, Year 6, and our Year 7 students. But what happens when we're working with numbers that are a little bit more awkward? What if we had 0.07? How would we turn that one into a percentage? The process stays the same. We're still going to grab our numbers and move them over. So we're not going to worry about the first 0. We could technically move the second 0 if we wanted 2 spaces so it lands in our tens column, but I'm more interested in the actual numbers. So this 7 is going to move over 2 places and land itself in the units column. So that tells us that 0.07 multiplied by 100 gives us 7. In a bigger picture, when we're looking at the conversion between decimals and percentages, that means that 7, or I guess 0.07, as a decimal, changes to 7%. So those zeros in the middle are going to impact how our number is seen or converted into a percent. So again, take a moment, write that one down, and I'll show you one more example that we're likely going to see a little bit further along our educational path, probably more so heading into our GCSEs. So when we are working, we may even see 1.32. And we need to multiply that by 100. Now I don't even have the boxes for it, so we're still gonna go through the process though. We're gonna multiply it by 100, which means all of our numbers move over 2 spaces to the left. So I'm moving my 1 from my units, and it's gonna land in my hundreds column. I'm gonna grab my 3 from my tenths over the decimal into the units, landing in my tens column. And I'm grabbing my 2 from my hundredths, moving it from the tenths over the decimal into the units column. That means that 1.32 converted into a percent is 132%. This makes sense. It makes sense because we know that 1 whole is equal to greater than 100%, or equals 100%. When our decimal includes a whole number, that shows us that our percentage is going to be greater than 100%. All right, make sure you have that all written down nice and neat in your notebook and follow me to the next section. We are now doing the opposite, so going from a percentage now to a decimal. So again, if we begin with our percentage, let's say we're starting with 87%. What we are now doing is dividing that by 100. Now, for some of our students who are a little bit more visual, one of the ways that I like to remind them that we divide by 100 is by looking at the actual percentage sign. Now, that percentage sign has 2 things that we can investigate, but I'm going to show you only one thing for right now. This percentage sign kind of looks like a division sign, which helps us to remember that to go from a percent to a decimal, our process is through division. Another thing that I find really interesting is that it has a line and 2 dots. A line and 2 dots is very similar to showing us 100. So 87% divided by 100 is how we exchange 2 decimals. So let's look. We have 87. We know that to divide by 100 means that we move our numbers 2 spaces. Now we're getting smaller because we need to go into a decimal, so we're moving to the right. So I always start now with my smallest number. It's easier to move that one past the decimal into the tenths, landing in the hundredths column. Grab my 8 from the tens, it passes over the units, over the decimal, lands in the tenths column. Don't forget to place your decimal and your starting 0. So that tells us that 87% divided by 100 gives us 0.87. So that's how we can move from a decimal to a percentage. Now, when might we want to go from a decimal to a percent, or a percent to a decimal? If we're trying to figure out how much money we get to save, or we need to put aside as a savings, let's say we said that we wanted to save 87% of every 100 pounds, then we would need to know that 87% is 0.87, so then we can multiply it better. You can't multiply 87% with a full digit because they're different formats, and so we need to put them into the same format in order to work with them. So that's what we would do. We would turn our percentage into a decimal, and then we'd be able to multiply it by the number that we're working with. So again, go ahead, pop that in your book. When you're ready, let's move to another example. Let's take a peek. If we had the percentage, let's say 4%, we know that we need to divide by 100 still. And we also remember that last time when we were multiplying, we ended up having a number that was on the 100th side. So if I start first, my 4% starts in my units. And I'm going to move it backwards 2 places to land it inside my 100th section. I'm going to place my placeholder 0 because it needs to have something in between the decimal and the 4 and that digit in the hundreds column. Otherwise, it's just going to look like it's in the tens column. So we put in a 0 to show that we've taken up that space. So 4% changes to 0.04. All right, finally, go ahead, make sure that's in your book, and when you're ready, we keep going. Sometimes we can see our percentages are above 100, and so we start by placing them in our place value chart. We actually don't have a hundreds column, but let me just note that it is here, because if we're working with 157%, my 1 needs to live in that hundreds column. So 157, written in our place value chart, I know that I am dividing by 100 to move from a percent to a decimal. So I'm going to grab my smallest number, move it 2 spaces to the right, jumping over the decimal, landing into the hundreds column. Grabbing my 5 from the tens, over the units, over the decimal, landing in that tenths column. Placing my decimal if it's not already there, and then grabbing my 1 from the hundreds, moving it 2 spots to the right, landing in that units. So now I can see that 157% is the same as 1.57. Okay, so now we've gone through percentages and decimals, as well as fractions to decimals, and the other one, decimals to percent. The only one that is now left is our percent to fractions. So let's make sure we understand our percentages. We see here that percent is written 57%. As I was saying earlier, percentages is per 100. So I have 100 grid square on the screen. What 57% means is that we have colored in 57 out of the 100 squares available. That is our 57% covered in. So knowing that, we can use this to our advantage as we move through. Now we have our 57%. Our process to go from a percentage to a fraction says that we put the percent over 100 because per 100 means out of 100, and we simplify. So 57 lives over 100, and then we simplify. But what does it mean to simplify? For some of our younger students, they still may not remember that simplifying means that we need to bring our numbers down to the smallest possible option. A really good thing to do is note down these 3 questions that are going to help us to determine if we can simplify and how we go about it. In order for us to start, we look at the first one. It says, is it a prime number? Now, for us to answer that question, we need to know what is a prime number. So a prime number is a digit that only has 1 and itself as factors to give us our answer. Another way of looking at it, it means that only 1 can fit into that number, 1 in itself. So I've gone ahead and shown us on this 100 square what all of your prime numbers are. It's really important for us to know them. When we are in a younger school, probably around year 6, they will have the expectation that students know their prime numbers up to 100. So you've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 83, 97. Now, why is 1 not a prime number? 1 is not a prime number because a prime number needs to have 1 and itself in order to count, and no other option is possible. 1 is 1, so it's 1, but it's not itself. Basically, it doesn't count as a prime number. So don't be mistaken by that one. Okay, so is 57 a prime number? No, it's not a prime number, which means we move down to the next question. Does it end in a 2? No. Does it end in a 5? No. Does it end in a 0? It should say a 0. It's not going to end in a 10. It's going to end in a 0. And the answer is no. So we go down to the next question. Is it divisible by 3? So we can do some quick maths on this, or we can do short division. So 57, is it divisible by 3? 3 goes into 5 one time, 2 remaining. 3 goes into 27 9 times. Is it divisible by 3? Yes, it's divisible by 3. Now, we have to check top and bottom. So yes, we can simplify the top, but can we simplify 100? Is 100 divisible by 3? No. So we move to the next one. Is it divisible by 4? Can 4 fit into 57? 4 goes into 5 one time, carry the 1. 4 does not go into 17, so it's not divisible by 4. Is it divisible by 7? 7 into 57. 7 doesn't go into 5, so we need to know, does it go into 57? Well, let's use our 7 times tables. What's one that's probably quite close? We know our 7 times 2 is 14. What's 7 times 5? 7 times 5 is 35. So that's quite close. But let's go a little bit higher. What's 7 times 7? We should always know our number times itself. 7 times 7 is 49. Do we know 7 times 8 off by heart? Maybe not. So let's count from 49. 49, 50, 51, 52, 53, 54, 55, 56. So can 7 fit into 56? Not without any remaining or continuing. So is it divisible by 3, 4, or 7? Yes to 3, but 100 is not. So no, this means that we cannot simplify 57 any further, and our fraction remains 57 on 100. So that's why it's so important for us to know our times tables and to understand which numbers are prime numbers as well. Let's look at another question. Let's look at 63. First question, or the first step that we have to do, is turn our percent into a fraction. So we said we put it over 100. Okay, now we need to decide if we're going to simplify. So the first question says, is it a prime number? Knowing my prime numbers, no, it's not a prime number, which means we're likely able to simplify it. That's what that means. Does it end in a 2? No. Does it end in a 5? No. Does it end in a 0? No. Okay, we keep going. Is it divisible by 3? Well, it ends in a 3, and 6 plus 3 give me 9, and 9 is a multiple of 3, which means it's in the 3 times table. So it's a very likely chance that it is divisible by 3. So what we can do again is short division, just to double check. So 3 can fit into 6 twice, and 3 can fit into 3 one time. So is it divisible by 3? Yes, but 100 is not. So we can't use that as an option. But is it divisible by 4? Let's check. 4 can fit into 6 one time, 2 remaining. But 4 can't fit into 23. It goes between 20 and 24. So we know we can't divide it by 4. Then we have to see, can 7 fit into 63? Then we have to see, can 7 fit into 63? So our last one is going to determine, can 7 fit into 63? So 7 on the outside, can 7 fit into 6? No, so that means again we need to know our 7 times table. Let's go to one that we just talked about that we know off by heart. 7 times 7 is 49. So 7 times 8 we know is 56 because we've jumped up. And then 7 times 9, well, we can use our fingers for that. So when we do our 9 times table, if we put down the one that we're looking for, whatever's left are the digits. So with your fingers held out, we go 9 times 1, we put that 1 down. That leaves us with 9. 9 times 2, we put the second finger down. Whatever's on the left side, that is our tens column. So this becomes 18. If I put down my third number, that becomes 27. Fourth number, 36. Fifth number, 45. Sixth number, 54. Seventh number, 63. So can 7 fit into 63? Yes, 9 times, but does 100 get divided by 7 with no remainders? No. So can we simplify 63? No, we can't simplify this fraction, 63. It stays as is. Okay, now I have a little bit of a challenge for you, but don't worry. As always, the homework that I give you, you're more than welcome to send it over to me. I'll put my email on the screen and I will happily respond back to you with a Loom video, which means I'll show you your work that you've done. I'll show you how I've marked it, and I'll even give you a step for how you can improve and go a step further. So let's look at what this challenge is for this week. I'd like to know what 4/5 into a decimal looks like, as well as a percentage. I'd like to see what 0.32 as a fraction is in its lowest form, as well as a percentage. And I'd like for you to change 65% into a fraction and a decimal. So when you're going through it, I'd like for you to, again, if you need any help, please don't hesitate, send it over to me and I'm happy to mark it for you. Let's look at one more step because I think it's really important that you see why we need to understand conversions and how you'll see it in the future. Now, one of the biggest ways that we'll need to understand conversions is when we are asked comparison questions. So this comparison question says, which is bigger, 2/3 or 0.65? So what we have to do is change these into a format that we can compare between. So if I put 0.65 as a fraction, it will turn into 65 over 100. And right here, I've got 2/3. Now this is a simplified version, 2/3. What I need to do is see if I can build it up. Now 3 doesn't fit into 100. Okay, so one of the ways that we are going to understand why we needed to know how to convert is when we get to questions that ask for comparison. Now in this case, we have 2/3, which is our fraction, and we want to know if it's bigger than 0.65. So the first step is to put them into the same format. Now, if we put 0.65 into a fraction, we'll see right off the bat that 2/3 and 65 over 100, they're not very easy to compare because we can't simplify the 100 down so it's comparable to 3. So what we have to do is change our fraction into the decimal. Now you're thinking, well, this is a really awkward fraction. It is, but I'll give you a tip. Nothing changes in our format. We grab our denominator, we place it on the outside of our fraction, and we divide. Can 3 go into 2? No. Put your decimal, carry your 0. I'll make sure it looks like a 0 and not a 6. There we go. Can 3 fit into 20? Yes, it can fit into 20. How many times? Well, 3 times 6 gives us 18. We'll have a leftover 2, which we add to a placeholder 0, which again gives us 20. 3 goes into 20. Yes, 6 times with 2 remaining added to a placeholder 0. What do you see is happening? We have a repeating decimal. So we have 2 over 3 giving us 0.66 recurring versus 0.65. When we're comparing our fractions, we look at the digit that's on the inside first. So the one closest to the decimal, we look at that one first, our tenths column. So both of them have a 6. However, when we look at the hundredths column, we can see that 2 over 3 has the decimal 0.66. It has a 6 in that space, whereas our decimal was 0.65. So we can see that 66, 0.66, is in fact greater than 0.65. Now, it's important for us to feel confident with some of these fractions. A really good way to do it is to just memorize some key ones. So understanding that a quarter is the same as 0.25 or 25%. A half is 0.5 or 50%. 2/3, or I guess we'll even start with 1/3. 1/3 is 0.33 recurring or 33% recurring. So understanding a couple of these more common decimal fraction percentage conversions is going to help speed everything up for you. But at the end of the day, understanding the process is going to ensure that you will always get full marks. Okay, so if you are looking for a couple of things that you can do in your day-to-day to ensure that your child feels confident in these conversions, they're on the screen here. When you're at the supermarket, you can ask your child to estimate sales price. When you're cooking, you can convert amounts between fractions and decimals. When you're on the road, you can use fuel efficiency, so miles per gallon, or I guess we don't use miles per gallon, but you can discuss percentages. For sports scores, you can discuss win percentages and averages, which is really helpful around rugby season and football season. And then when you're looking at pocket money and savings, you can ask simple math questions like, if you save 20% of your allowance, how much is left? Now, as I've mentioned, the category of fractions, decimal percentages is vast. It's like I said it's like I mentioned in the social media reel. I said that fractions is kind of like the French language, and decimals is like the Danish language, and percentages like speaking Polish. All of them have their own way of communicating, but they all fit under the umbrella of languages. So when we're talking about fractions, we've got adding fractions, multiplying fractions, fractions of a whole number. When we're talking about decimals, we have dividing, multiplying decimals, comparing decimals. When we're talking about percentages, we've got conversions, we have tax, we have increasing by percentage, decreasing by percentage, compounding interest. There's so many things in each of those different languages. That's why it's really important to understand the basics of how we can convert them, because you might find that you speak more fluently in decimals than fractions, or fractions than percentages. And that's okay. As long as we understand how to convert them, you will be able to use those skills throughout your entire academic career and beyond. So that is it for this week's Secrets of a Maths Tutor. I hope it was helpful. Like I've mentioned, you're more than welcome to answer our questions and send them over to my email address, which is at the Bettering Youth website. And the Bettering Youth website, as you can see, is down below, www.betteringyouth.co.uk. If you have any questions or if your child would benefit for some one-to-one maths tuition, it doesn't matter if they're getting ready for their SETs, the 11 plus, entrance exams, GCSEs, anything in between, we are more than happy to help. Have a great weekend and we'll see you next week.